Alright, in this quick video we're going to go over the properties of logarithms. Now I have just some example problems here, and I also have the rules from the Britannica.com, which has a nice little layout of all the rules here. And so we're going to use this as a basis when we start working these particular problems. Let me leave a little bit of room here. I'll move this up a little bit, and we'll kind of make enough room for this thing to show its face right down there. Alright, so with this said, we are going to be working with, if I can get this moved up here, properties of logarithms. Okay, let me clear all this junk out of here. Now with this said, you guys have been working with this for a little while in class because we've had these written up on the boards for a while. There is kind of a larger list that kind of deal with some of the identities, but this is kind of the basic stuff that we're going to use, particularly the powers rule, which is log base b n to the p is equal to p log base b of n. Alright, so let's look at this first problem right here. I'm going to kind of walk through what we're going to use here. So we have log base 3, 12 to the third times 5 to the fourth power. The entire quantity is being taken to the fourth power. Now if you look at this, the powers are right here, we're taking an entire quantity to a power. So that can be rewritten as the power up in front. Right? So what I'm going to do is kind of drop this down here. So we have 4. This is this 4 dropping back down in here. And we have log base 3 12 to the third times 5. Okay, so we've taken care of that 4. He's going to come up front, and now we have this particular problem. We're taking this term times this term. Okay, so if we look at this, this would deal with products. So instead of writing m times n, I'm actually going to write log base bm plus log base bn. And so we're going to keep this 4 right here because that's going to be kind of a standard at this point in time. So we have 4, and then we have log base 3 12 to the third plus log base 3 times 5. Okay, now we'll put that 4. I just didn't put the 4 on there because I had to put it in blue, and so that's that 4 just kind of still staying in the problem here. All right, so now we have log base 3, 4 times log base 3 of 12 to the third plus 4 log base 3 of 5. Now you'll notice that again we have this same thing of powers, meaning we're taking our object that we're the logarithm to the third power. So we're actually going to move that up front again. So now we're going to take this 3 and multiply up here. So we have 12 log base 3 12 plus 4 log base 3 5. Okay, so that is our end answer, and I know it's kind of weird because you're kind of like, when do I finish? Well, you really kind of finish when you are not taking kind of anything times itself, or you're not taking anything to a power, because we can eliminate all that stuff, okay? Or any radicals, which we'll kind of get into with this particular problem, okay? So let me take a moment to erase that. Let me move this over just a tad here. Kind of erase that stuff there. Hey, a bigger eraser. This is nice. Alright, so we worked a similar one like this in class today. These numbers do not associate with your numbers from your worksheet you got today. We have ln 7 times the square root of 6 times 5. Now for this case we could say that 6 times 5 is 30, but we're kind of working with these logarithmic properties and kind of working around these. So what we have here is we're taking a term times another whole kind of quantity, but we're not taking anything into a power. So we can just break that up using the products rule. So we have ln 7 plus lm, and instead of the square root of these numbers, I'm actually going to say 6 times 5 taken to the 1/2, which is the same exact notation. But writing in this notation informs me what I'm going to do next. So now I have ln 7 plus, because we're taking something to a power, we're going to stick it up in front. So we have 1/2 ln 6 times 5. Now we're not quite done yet because we're taking a logarithmic function with of a multiplication. So again we have to use the product rule, and so we'll get ln 7 plus ln, don't forget about that half ln 6 plus half ln 5. Okay, now make sure ln is just the same as writing, I got that's a bad ln, the same as just saying log base e. It's the abbreviation for this, an important function or important number in exponentials. Okay, especially when we get into calculus, we'll talk about that a ton. All right. So this is my end answer, and notice how the half only associated with this. It didn't come back to the 7 because once they're separated, they're no longer together. Okay. So that is another example, and then I just wanted to work one of these examples where we had a division problem going on because we didn't quite have those on our practice problems. So let me quickly work one of those particular problems. So we have log 8 parentheses u to the 5th, or u over v to the 6th to the 5th. Now take a moment and see if you can just answer this question without me working it, and take a pause right now. Okay, I assume you took a little bit of a pause to solve this problem. Now what you would do here is we still have our quantities being taken to a power. So the first thing we're going to do is that's going to drop down into the front. So we have 5 times log base 8 of u over v to the 6th. Now with division, you can kind of see how this works. The ratios right here is that when we have division, instead of an addition sign, we're just going to subtract. So we have 5 log base 8 u minus 5 log base 8 v to the 6th. Alright? So you'll notice that this 5 followed both logs because it was at the beginning of our problem. And this guy is done because he's not taking any power. I have no multiplication or division or anything going on. But this guy's being taken to the 6th. And so we can multiply that out. And we're left with 5 log base 8u minus 6. Or, sorry, 6 times 5, which in this case would be 30, because we would drop that 6 times 5 over, and so we would be left with 30 log base 8v. Okay? So, hopefully this is a good example of the expanding each logarithm, and you're kind of getting that down. Now I'm just going to do a couple quick examples of the condensing portion, which we might get more to tomorrow, but a little preview of what it's going to be, and I'm going to create another video that based on that. But if we have, for example, number 11, I'm going to get off. I'm going to go pen instead of pencil. If we have the number 11, we have 3 log base 7 of 3 plus 12 log base 7 of 5. Okay? So what we have here is we're going to kind of work backwards now. So we know that if there's a number out in front of the log that it was originally a power. So with that we can kind of say, all right, log base 7 3 to the 3rd plus. Same thing here, we could say log base 7 5 to the 12th. Okay? Very similar to a problem we had today in class. Might have been like your first one you did. And now what we're going to do is, because this is plus, we're going to multiply these together. So it really stands for log base 7 3 to the 3rd times 5 to the 12th. Okay, because it was addition, now it's multiplication, and we're working our way backwards. Now if you want to get really fancy, which I think a couple of you guys did, is we could rewrite this as 3 times 5 to the 4th taken to the 3rd power. Now I want to ask you guys something, because it looks like it works because of the fact that we're just simplifying and we could distribute this, but would this really change your answer? Maybe try expanding it out and see if you come up with the same exact answer here. Alright, so that was just an example of condensing. I will make an additional video that discusses this tomorrow. But come with this with like a basic knowledge here and we'll be ready to go. So have a great night, and I'll see you all tomorrow.